We're going to discuss a few types of properties of numbers. Properties of numbers would be things like the additive identity, the multiplicative identity, the commutative property of multiplication, etc. So we're going to talk about those briefly. So first we're going to start with the additive identity. So I have an ID here. If I took this ID and I added nothing to it, is it still just the ID? Yeah. Okay, so what would that mean mathematically? Let's call that ID 5. Okay, let's just change it to a number. It's 5. Okay, if I add nothing to it, how do I represent that? That's like adding 0. If I add nothing to that, it's still itself, right? 5 plus 0 is 5. So the additive identity is when you add 0, the number is still the same. Now let's talk about the multiplicative identity. What's any number times 1? You should say itself. So let's do, for example, let's keep it 5. What's 5 times 1? Everyone should tell me 5. So if I say there's one of those, kind of like think about, if you say that times 1, times 2, times 3, times 4, that means there's 1, 2, 3, 4, 5 of whatever those are. So if there were 5 IDs, that would be IDs times 5. Well, if I said there was one ID, that would be ID times 1. So the multiplicative identity is like the identity of, remember that we did 5 as our identity. So multiplicative identity, we would say that's the ID times 1. It's still itself. In both of those examples, we still have itself, and that's its identity. Its identity does not change. Who you are is still who you are if I add nothing to it. So now we're going to talk about the commutative property of multiplication and the commutative property of addition. The root word to commutative is commute, as in like a car. You get in the car and you ride downtown, you commute. So like your parents drop you off at school and they go, bye, see ya, downtown. Okay, they commute, right? Okay, same thing with our numbers. Let's say the commutative property of multiplication. If we had 5 times 7, we could also say 7 times 5, and we will get the same answer. They both are 35, right? Okay, the commutative property of addition. Let's do 3 plus 4. We could also do 4 plus 3. And either way, we are going to get 7. So we can move those around. We can commute with them and get the same thing. So now let's talk about the associative property of multiplication. Okay, so as you can see, I've got Virginia, Sophia, and Avery. Okay, let's say the three of them represented 3 variables, V, S, and A, or they could represent numbers. But I'm going to keep it with the variables since we're dealing with pre-algebra. All right, so I've got V, S, and A. And if V, S, and A are sitting like that, as in like 3 variables together, that's like saying Virginia times Sophia times Avery. V times S times A, correct? All right. But now let's say I've gone and put some parentheses around them. So I put parentheses around Virginia and Sophia. Now what that means is, thanks to the order of operations, instead of just multiplying wherever, I would say Virginia times Sophia comes first, and then I would do times Avery. But I'm going to get the same thing as if I moved it around, right? Or am I? Meaning, what if I move the parentheses over here? Now it says Virginia times, and then over here I'm associating Sophia and Avery first. So now let's look at this as like a big picture. If I did Virginia times Sophia first and then did times Avery, or if I did Sophia times Avery and then did times Virginia, I'm still going to have the same thing. So if I associate Virginia and Sophia with Avery, or if I associate Sophia and Avery with Virginia, I'm still getting the same thing. So this parentheses right here mean it does not change that value. That is the associative property of multiplication.